Welcome to MS 100 lessons, and in this lesson I will be doing a past paper question on Newton's laws. So with this example, I want us to apply the steps that we use in order for us to analyze this question. So I'll start by reading the instruction. The instruction says, a light inelastic string connects two blocks, right? So this should be inextensible. The string should be inextensible. So if we have a string, then it means there is tension that will act on that string. Okay, so remember that string should be inextensible, right? So a light string connects two blocks of mass 6 kg and 3 kg respectively. So with the 6 kg we can calculate our Fg, right? And with the 3 kg we can also calculate the Fg for the 3 kg. So we have two blocks, right? So Fg for the 6 kg, Fg is equals to mg, right? Which is the mass multiplied by gravitational acceleration, which is 9.8. So 6 multiplied by 9.8, that will give us 58.8 newtons downwards. Okay, so that is the magnitude and direction for Fg for the 6 kg, and we can also calculate Fg for the 3 kg, and that would be Fg equals to mg, the mass is 3 multiplied by 9.8, right? And that will be 3 multiplied by 9.8. Okay, and that is 29. That is 29.4 newtons downwards. Okay, all right, so they are pulled up an inclined plane that makes an angle of 30 degrees with the horizontal. So we can see that this is an inclined plane, right? And they are pulled apart with a force of magnitude F. So we are not given the magnitude of the force F, so they just said it's force F. So ignore the mass of the string. All right, so as you can see, this is the diagram. We have our inclined plane, which is inclined at 30 degrees from the horizontal, and we have two blocks moving on that surface, right? So they say the coefficient of kinetic friction, the fact that they're saying there is kinetic friction, right? Kinetic means the objects are moving, and there is friction, then it means the surface is rough. Okay, so we have a rough surface. So the coefficient of kinetic friction for the 3 kg object and the 6 kg object is 0.1 and 0.2 respectively. So it means for the 3 kg, right, we have 0.1 for the coefficient, and for the 6 kg we have 0.2. Okay, so those are the coefficients of kinetic friction. So now we have to perform our analysis, right, without looking at any intermediate statements, the statements that are given inside the question, right, or any values that are given in the questions. Let us look at the main statement first. The main statement ends here, right? So we have to apply our steps that we follow in order to make our analysis, right? For us to perform our analysis, remember step number 1 is separate. Okay, so what does this separate mean? It means we will be applying Newton's laws on this object and Newton's laws on the second object separately. Okay, and then step number 2, we draw our free body diagram for both objects. Okay, so we'll draw the free body diagram for the 6 kg and we'll draw the free body diagram for the 3 kg. And then the next step, we have to resolve. Okay, so what are we actually resolving? We are resolving any forces which are not in the x direction and y direction. Okay, so let us note that for this question now, since we have an inclined plane, the system of axes that we're going to be using will be like that. Okay, we'll have the x axis and the y axis, and that is the positive axis, x-axis, that is the negative x-axis. Okay, and that is the positive y-axis and the negative y-axis. So the system of axes that we'll be using in this question will be like that. Okay, so it means we're going to be resolving any force which is not in that y direction and any force which is not in that x direction, right? So we'll resolve that force into the x and y direction. Okay, so that is step number 3. We'll be resolving using this system of axes. And then the next step, so after resolving, perform our F net in the y axis. Okay, so that is F net equals to MA in the y axis, and the main reason we do this is to obtain the normal force, right? And after obtaining the normal force, we obtain our friction. In this case, that would be kinetic friction since the objects are moving. Okay, and then step number 5, we perform our F net in the x axis, right? And then the last step is to solve any unknowns. Okay, so now let us perform our analysis. Before answering any question, let us perform our analysis from the statement that we have read so far. So now step number 1, we separate. We agree that we'll be performing, or we'll be applying Newton's laws on the 6 kg and Newton's laws on the 3 kg separately. So we are done with step number 1. Step number 2, the free body diagram. Remember, you have to draw the free body diagram for both objects, right? So let us do step number 2. So step number 2, I will draw my free body diagram for the 6 kg block. Okay, and then I will draw the free body diagram for the 3 kg block. All right, so free body diagram for the 6 kg block. Let us look at the forces. And remember now our system of axes that we are using, that system of axes, right, where we have the x and the y. So that is the surface on the free body diagram, and make sure that your normal force is perpendicular to the surface, right? Okay, and the object is moving up the incline, right? So that is the direction. So why am I indicating that direction? We have to make sure that the friction is opposite to that direction. Okay, and why am I including the surface here? I have to make sure that my normal force is perpendicular to this surface. Okay, but you don't have to include it for the free body diagram. I'm just including it so that we must make sure that our normal force is perpendicular to the surface and the friction is opposite to the direction, right? Because as you can see, the objects, they are being pulled up the incline, right? And this means that if there's any friction, it will act down the incline. All right, so let us look at the free body diagram for the 6 kg. We have a surface here, right? It means we should have a reaction force, which is the normal force, which is perpendicular to the surface, right? And we also have a mass of 6 kg, then it means we have gravitational force going downwards, right? We have tension in that direction, which is pulling the 6 kg block, right? So we will have tension in that direction. But now remember that the surface is a rough surface and the object is moving up the incline, then it means the kinetic friction will be pointing down the incline. Okay, so those are the forces that are acting on the 6 kg block. So for the 6 kg block, we have Fg, which is always downwards, right? And we have normal force, which is perpendicular to the surface. Okay, and we have tension, which is moving up the incline, and we have friction, which is down the incline. Okay, so those are all the forces that are acting on the 6 kg block. So now let us draw the free body diagram for the 3 kg block. So for the 3 kg block, if we look at the object up there, we have a mass of 3 kg, therefore we have gravitational force going downwards, right? And we have a surface there, we have the normal force, which is our reaction force. Okay, we have the normal force, which is perpendicular to the surface, right? And we have our applied force, which is up the incline. We have tension, which is down the incline. And remember that the surface is rough, then it means we have friction. Okay, so let us indicate all those forces acting on that object. I said we have Fg, which is downwards, right? And I have normal force, which is perpendicular to the surface in that direction, right? I have my applied force in that direction, which is up the incline, okay? And I have my friction, which is down the incline, and I also have the tension, which is pulling back the object, okay? Because the tension is pulling up this 6 kg, but it is pulling down the 3 kg, right? And the magnitude of that tension is equal. All right, so these are the free body diagrams for the 6 kg and the 3 kg. So now let us look at the next step. What is our next step? The next step is to resolve, okay? So let us see which forces are not in the x direction or the y direction. So remember, that is our x direction from that system of axis, and that is our y direction. So for free body diagram number 1, we have the normal force, okay, that is in the y direction. In this case, it's in the positive y direction. Tension, positive x direction. Friction, negative x direction. But what about Fg? Fg is not in the y direction and it is not in the x direction, right? So it means we have to resolve that Fg. Okay, so when we resolve Fg, we actually have to draw another free body diagram, right, to represent that we have resolved that Fg. So, but for this video, I'm going to be resolving it on the same free body diagram, right? So let me resolve Fg. When I resolve Fg, I will have Fg perpendicular. And why do we say this is Fg perpendicular? It is because it is perpendicular to the surface, right? As you can see, the orange line there, that is the surface. So it is perpendicular to the surface, right? And I also have Fg parallel, right? And that is parallel to the surface. So now, since I have drawn those components, I can now remove this Fg, right? Okay, so now, but for you, you have to draw another free body diagram, which is resolved, right? So you'll have the original free body diagram and the resolved free body diagram, okay? But now I have erased that Fg and represented that Fg in terms of components into the Fg perpendicular and Fg parallel. So as you can see now, Fg perpendicular is in the y direction, right? And Fg parallel is in the x direction. So in this step of resolving, we also have to note that Fg parallel is equal to mg sine theta, and that it is the angle of inclination, right? And Fg perpendicular is equal to mg cos theta, right? By calculation, what is m? The mass is 6 kg, okay, and then g is 9.8, okay, and then the angle of inclination, it's 30 degrees according to the question, okay. All right, so we have sine 30, and that will give us our answer. And then let's look at FG perpendicular. There would be 6 kg for the mass, 9.8, and then cos of 30. Okay, so when you resolve, you have to show on the free body diagram and just do these calculations for our analysis, right? So that would be 6 multiplied by 9.8, okay, multiplied by sine 30, and that would be 29.4. So we have our FG parallel for the 6 kg to be 29.4, and for the second component, which is FG perpendicular would be 6 multiplied by 9.8, cos 30. Then I have my component to be 50.92 newtons. Okay, so I have resolved the free body diagram for the 6 kg. Now I have to resolve the free body diagram for the 3 kg, right? So remember, that is step number 3. And looking at this free body diagram, we have the normal force. The normal force is in the y direction, so there's no need to resolve the normal force. F applied, it's in the x direction. Fk, x direction. Tension, x direction. But Fg is not in the x direction and it is not in the y direction, so we have to resolve Fg. Okay, so let us now resolve that Fg. So when I resolve Fg, I will have Fg perpendicular and Fg parallel. Okay, and then I will erase the Fg because I've represented Fg in terms of components. Okay, so let me perform these small calculations for resolving. I have Fg parallel, which is equals to mg sine theta, okay, and Fg perpendicular is equals to mg cos theta. Remember, we are now performing this calculation for the 3 kg, right? Okay, then there would be m, which is 3 kg, and then g 9.8 sine 30. Okay, and for this one we have 9.8 cos 30 degrees. Okay, so let us see what is the magnitude of Fg parallel for the 3 kg. That would be 3 multiplied by 9.8 multiplied by sine 30. So we have 14.7 newtons. Okay, and Fg perpendicular, we have 3 multiplied by 9.8 multiplied by cos 30. Okay, then we have 25.46 newtons. All right, so those are our components. Okay, so now we are done with step number 3, which is resolving, right? We have resolved Fg in this case for both objects. Okay, let us go to step number 4. Step number 4, we apply the net force in the y direction. And remember, the net force in the y direction is for us to obtain the normal force, right? And also obtain the kinetic friction. All right, so let us go to step number 4. So let's apply F net in the y direction for the 6 kg. Then that would be step number 4, right? Step number 4, that is F net equals to ma. Remember, in the x direction, right? So how many forces are in the x direction? Oh no, we should perform in the y direction first, right? So how many forces are in the y direction? So we have 2 forces in the y direction, which is the normal force and Fg perpendicular, right? Normal force will be positive. Remember our system of axes that we always use. We say that is positive and that is negative, right? That is negative and that is positive. Normal force is acting in the positive direction, so that would be positive and minus Fg perpendicular. Fg perpendicular is negative, right? That is equal to the mass, and mass is a scalar quantity. There's no need to include the direction. And now what about the acceleration? These objects are not moving in the y direction, okay? So it means the acceleration in the y direction is equal to 0. So we'd have mass multiplied by 0, and that is normal force minus Fg perpendicular, that is equal to 0. So my normal force is equal to Fg perpendicular for that object. And remember, we have calculated our Fg perpendicular to be 50.92 up here, okay? So it means the normal force is equal to 50.92 newtons. So that is our normal force. And remember, after obtaining the normal force, you go straight away to calculate your friction. Okay, because remember, in our steps, step number 4, when you perform your Fnet in the y, you have to get your normal force. We have obtained our normal force. Now we have to calculate our friction straight away. Okay, and remember, the coefficient of kinetic friction for the 6 kg is 0.2. Okay, so we'd have our kinetic friction being equal to 0.2 multiplied by the normal force, which is 50.92. Okay, then Fk is equal to 0.2 multiplied by 50.92. So that would be 10.184. So that is our kinetic friction for the 6 kg. So now let us perform the Fnet in the y axis for the 3 kg. Okay, so Fnet in the y for the 3 kg, how many forces do we have acting in the y direction? We have 2 forces, which is the normal force positive and Fg perpendicular, which is negative, right? So we have normal force minus Fg perpendicular, and that is equal to the mass of the object, and the acceleration is equal to 0 because the objects are not accelerating in the y direction and they're not moving in the y direction. Okay, so they are stationary in the y direction. So now that would be the normal force minus Fg perpendicular equal to 0, and normal force is equal to Fg perpendicular. And remember, we have calculated our Fg perpendicular up here to be 25.46, right? So it means that is 25.46 newtons, right? And from this, we have obtained our normal force. And after obtaining the normal force, we go straight away to calculate our friction for that object, okay? And our friction would be, remember, the coefficient of friction between the surface and the 3 kg was given as 0.1. Okay, so that would be 0.1 multiplied by 25.46, right? So the friction now for the 3 kg would be 0.1 multiplied by 25.46, right? And that would be 2.546 newtons. Okay, so we are now done with the Fnet in the y-axis. So now we can go and calculate the net force in the x-axis, right? So Fnet in the x-axis, and that is step 5, right? Fnet in the x-axis, Fnet equals to ma. And how many forces do we have acting in the x-axis? We have 3 forces in this case, right? We have tension, which is positive, and then we have friction and Fg parallel, which are negative, right? in the x direction. So we have tension minus Fk minus Fg parallel, and that is equal to the mass of the object, okay, and acceleration. And remember now the acceleration, these objects are accelerating upwards, right? They're moving upwards, so the acceleration is positive, acceleration positive a, right? So that would be tension minus, remember we have obtained friction in the y direction, which is 10.184. That would be minus 10.184, right? Minus Fg parallel, and Fg parallel we have calculated in step number 3 where we were resolving. Fg parallel is 29.4, okay, and that would be 29.4, and that is equal to the mass of the object, 6 kg, and multiplied by the acceleration, okay. So here we'll have t being equal to negative 10.184, right, minus 29.4, okay, that would give us negative 39.584 equals to 6a. So that is equation 1. Let us leave it like that, right? And then let us perform the F net in the x direction for this one. Therefore, that would be F net equals to ma, right? So how many forces are acting in the x direction for the 3 kg? We have 4 forces, right? We have the applied force, we have kinetic friction, we have tension, we have Fg parallel. All right, so remember the applied force is positive and all the other forces are negative, right? We have applied force, which is positive, minus Fk, okay, minus tension minus Fg parallel, and that is equal to the mass of the object, and acceleration is positive because it is moving up the incline, which is in the positive direction, okay. So okay, the applied force we were not given, right? They said it is force F, okay. And then what about the friction? The friction, we have calculated it in the F net in the y direction, which is 2.546, right? So that would be minus 2.546 minus tension that we do not have, okay, minus Fg parallel. We have calculated Fg parallel when we were resolving step number 3. Fg parallel is 14.7 there, right? So that would be 14.7, and that is equal to the mass of the object. The mass of the object is 3 kg, okay, multiplied by acceleration that we don't have. So our equation would be F, okay, minus T minus, if I'm collecting like terms, that would be negative 2.546, right, minus 14.7, okay, then I'm getting negative 17.246, right, equals to 3a, and that is equation number 2. All right, so that was step number 5, right, which is F net in the x direction. So we are done with step number 5, and the last step is to solve, right? But if you look at the two equations now, we have equation number 1, which has two unknowns, which is the tension and the acceleration, and we have equation number 2, which has 3 unknowns, right, which is F applied, tension, and acceleration. So we cannot solve the two because we have more unknowns than the equations, right? So this is the end of our analysis. So now let us go look at the intermediate statements. What are they saying in the intermediate statement? So with the question, we have 2.1, which is state Newton's second law. That is a theory question. We'll state it. We're looking for the intermediate statements, right? Or let's just state it as 2.1, state Newton's second law of motion inwards. Okay, so 2.1, second law states that when a net force is applied, okay, when a net force is applied on an object, the object will accelerate, but that object will accelerate in the direction of the net force, in the direction of the net force, right? And the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Okay, so that was 2.1. And 2.2, how will the coefficient of kinetic friction be affected if the angle between the incline and the horizontal increases, right? So now this question is based on the relationship of between this angle, okay, and the coefficient of kinetic friction. And remember, the coefficient of kinetic friction is a surface property, right? It depends on the surface and the material that was used to make that surface, right? And it does not depend on this angle of inclination. Even if you increase the angle of inclination, the coefficient will remain the same because it is still the same surface, right? And it is still the same material of the surface. So now, with this question, how will the coefficient be affected if the angle of inclination changes, right? The coefficient will remain the same. Okay, the coefficient will remain the same. So 2.2, it will remain the same because that is a surface property and not, it does not depend on that angle. So the answer is remain the same. Okay, so let us look at the next question. Draw a labeled free body diagram indicating all the forces acting on the 6 kg object as it moves up the incline. The fact that it is moving up the incline, then it means friction should be down the incline, right? So we have already done this in our analysis, right? So 2.3 is from analysis, which is step number 2, right? So where is that free body diagram for the 6 kg? That is the free body diagram for the 6 kg, okay, from analysis. So that is 2.3. Remember, you can also draw the one without resolving FG, okay? So it's either you use this one with components, but the marking would be, these two components would be marked as one force, okay? So that would be one mark for the two components. All right, so the next question, 2.4 now. 2.4, calculate the tension in the string, right? If the system accelerates up the inclined plane at 4 meters per second squared. So now you are given the acceleration, okay? They gave you the acceleration to be 4 meters per second squared. So now from our analysis, right, from the steps, if we can go to the calculations part, starting from step number 4, right? From step number 4, we have obtained everything. We have obtained our normal force and the friction for both objects. So let us go to step number 5. That is where we have unknowns. So for step number 5, they are saying the acceleration is 4 meters per second squared, and they asked us to calculate the tension, okay? So now, if we go to F net in the x-axis, right, they gave us this value, which is the acceleration, okay? They gave us this value, which is the acceleration. So from these two, if I can insert the acceleration to be 4 meters per second from what they gave us, that would be tension minus 39.584 equals to 6 multiplied by the acceleration, which is 4, right? And that would be tension minus 39.584 equals to 6 multiplied by 4, okay, which is 24. And then I take that negative 39.584 to the right hand side of the equation, and it will be positive 39.584, right? And tension is equal to 24 plus 39.584. Okay, so that would be 63.584 newtons. So we have answered the question now. Okay, we have obtained 63.584 as our tension. Okay, and if we can insert our tension up there, right, we have acceleration as 4 and we have that as 63.584. We can now obtain our applied force. Okay, if this was moving at 4 meters per second squared up the incline. All right, so we have now answered the question. And this question was continuation from our analysis. Okay, which was F net in the X direction. All right, so 2.4.2, calculate the magnitude of F if the system moves up the incline at constant velocity. So with constant velocity now, the acceleration is no longer 4 meters per second squared, but now the acceleration is equal to 0 because the objects are moving with a constant velocity. So you go to the same step, which is step number 5, whereby now the acceleration is no longer it's no longer 4 meters per second squared, but it is now 0. Okay, so let me erase this. This was for acceleration, which was 4 meters per second squared, right? But now they are changing the acceleration. They're saying it is moving with a constant velocity. And if it is moving with a constant velocity, then it means acceleration is equal to 0. And we are required to calculate the magnitude of the applied force now, right? So that would be T. So let me use a different color for question for the following question, whereby acceleration is equal to 0. Then that would be T minus 39.584 equals to 6 multiplied by acceleration to be 0 because it is moving at a constant velocity. And as you can see, that would be 39.584 equals to 0, and our tension is equals to 39.584. Okay, so that is our tension, and we can substitute our tension in that equation now, whereby we'll have the applied force minus the tension, which is 39.584 minus 17.246 equals to 3 multiplied by 0, which is our acceleration, since they are moving with a constant velocity. So that would be F minus that would be minus 39.584 minus 17.246. Okay, that would be negative 56.83. That is equals to 0. Okay, so the magnitude of the applied force now is equal to 56.83 newtons. So we have now answered our question, right? And same thing applies. This was from analysis. This was a continuation from analysis, which was F net in the X direction. Okay, All right, 2.5. How will the tension in the string calculated in 2.4.1, the tension that we have calculated here, right? How will that tension be affected if the system accelerates up a frictionless inclined plane? So now they're saying there is no friction because it is frictionless, right? And now we want to see what will be the effect on the tension, which is in the rope, if the object accelerating up the incline at 4 meters per second squared, because we have calculated our tension, right, when there is friction, right? So we want to see how will it be affected. So now I want us to note that with the tension, we have the 6 kg, right? And we have the 3 kg up here, and we have tension right there. So remember, this tension is pulling up the 6 kg, right? So if it is more easier to pull up the 6 kg, that the tension would be low, right? But if it is more difficult to pull up the 6 kg, then tension would be high, okay? So remember now there was friction. Initially there was friction, okay? And we were pulling up this 6 kg and we got our magnitude from that 2.4.1. We got our magnitude for the tension that we have calculated, right? So now we are removing that friction, okay? So now when we remove friction, now it becomes easier to pull that object up the incline, right? So if it becomes easier to pull the object up the incline, so the tension will decrease, right? So it will be more easier to pull the 6 kg up the incline. So it means the tension will decrease, okay? So for 2.5, tension will decrease. So just note that every time you get a question like this, you have to perform your analysis, right? And then wherever you stop with your analysis, go and check the intermediate statements. Whatever values you are given inside the question, then you substitute in that analysis of yours, and then you'll get those answers. Thank you.